Following the dreadful gas explosion at Atomic Junction, Accra, Ghana, in the year 2017, the innocent public and owners of gas filling stations across the country continue to face fear in managing LPG filling stations. Gas explosions have caused loss of precious life and huge economic losses to owners of gas filling stations and the government as well. In the past 4 years, the rate of fire explosion in Ghana has risen steadily. If measures are not put in place, the nation will be thrown into another series of gas explosions. To avert this situation, our project presents a monitoring system for the early detection of LPG leakages using the concept of Internet of Things. In our literature review, the team stumbled across several papers written by researchers. But the most significant papers that stood across in terms of this project were design and construction of a GSM-based gas alert system by George in 2006. In this research paper, the researchers used Kill Microvision, which is complex to use, and also the test alert that were received, the precise value of the gas could not be read. Again, the second paper, which is an IoT-based smart gas monitoring system by Anand Kakrisman in the year 2017. They use the MQ2, which is the lower version of the gas sensors, which do not really have a much bigger range for detection of gas concentration. And they also use ESP8266, which is a Wi-Fi model. So looking at this, we decided to use a GSM model because in Ghana, the SIM card or GSM is the most affordable and the one that can be used everywhere.
After several literature reviews and material selection candidates, we settled on some materials for the project. LEDs for detection and signaling for the hardware parts. We settled on the MQ5 gas, temperature and humidity sensors, which are major sensors for studying the parameters of gas leakages and explosions. Having a buzzer to sound an alarm when there's a leakage on the environment was a great idea to help with the early detection. An LCD for displaying the sensor data values, and a GSM module for text alert and data publishing. All these sensors and many devices will be controlled by the microcontroller, which is programmed with the Arduino software.
And also, 2 LEDs, green and then red. The red is turned on when the gas concentration exceeds a certain limit, and the green is turned on when the gas is less than a certain limit. To clearly define what our system will do, the functional requirements of the system were clearly stated. First of all, the system should be able to detect and measure gas concentration, temperature, and humidity. The system should be able to display the sensor data that it has gathered on the LCD. The system should also push data to the cloud using the GSM model and be able to send a test notification when the gas leakage is higher. The server of the web application should receive and publish data in a database for reference and analysis. The buzzer should sound an alarm to alert station manager on the leakage of gas concentration. And finally, the web application should allow the user to locate the filling station. In coming up with our final design product, which is a printed circuit board, first we designed the schematic and the board using Eagle CAD software after simulating with Proteus Design Suite. The components were printed and soldered together as expected in the schematic. It is powered with a 9-volt battery, but 5 volts is being supplied to the system with the aid of a linear voltage regulator, LM805. The hardware is then programmed using Arduino software, and the unit test of each component is performed.
In selecting the right components for the system, it was important to use a Pew matrix and a literature review insight to guide the material selection decision. The Pew matrices included factors such as cost, feasibility, reliability, compatibility, power consumption in the feature comparison process. In comparing the number of design criteria or materials that best fit the design criteria, Pew matrices for the major categories were conducted. The Pew matrices that were constructed to analyze and decide amongst the several material candidates selected in the brainstorming phase. This allowed a comprehensive review of the available hardware components for the building the system.
Our prototype design made use of Arduino Uno board to achieve the various functionalities. The sensors, which include gas sensor, temperature and humidity sensor, were all interfaced with Arduino and the LCD. Components such as LEDs, buzzer, GSM were all incorporated to achieve detection and internet functionality.
Hi everyone, my name is Emmanuel Nimo and I'm the team lead for Team Alpha, representing Ghana from Ashesi University. So in this project, my team and I, we are developing an LPG monitoring system for early detection of gas leakages at filling stations in Ghana. For some time now, gas explosions have been very rampant in Ghana, and between the year 2014 to 2017, Nigeria Online, which is a news outlet, recorded that 8 gas explosions happened in the country. Because of this problem, our team, we took it upon ourselves to come up with a solution that can help us prevent gas explosions in Ghana. So in our design solution, we came up with a web application which has a graph and then a graph card with temperature, gas concentration, and then humidity. It displays all the value that is being obtained from the sensor. So right in front of me is my sensoring unit, which has 2 MQ5 devices and then 1 DHT22 for temperature reading. So when the sensor gathers the data, which is temperature, gas concentration, and humidity from the environment, it sends it to the microcontroller, and the microcontroller relays it to the GSM model, and the GSM model sends it over the internet to the web application where the data is being displayed. We also have a buzzer, which sounds an alarm when the gas concentration exceeds a certain limit. And when it exceeds a certain limit, the green LED shown here is changed to red. So in our test, we will be seeing that we will be applying a perfume which has a content of butane. So we believe that once we try that, there will be an increase in the gas concentration, and then the specified threshold that our program is supposed to do will turn the green LED to red LED. So we are coming to perform a test in case if there's an LPG leakage. So I'll be applying the perfume which has butane in it, and then we will get to know the test message. This is the phone for the station manager. So I'll be applying the gas in case if there is a leakage in the environment. Then we wait for a while, and we've set the threshold to be above 200 ppm. So in case if the concentration goes above 200, you're supposed to send the test message to the station manager. So while we wait for our test message to come, all right, so this is our test message informing us that the threshold has exceeded 200, LPG concentration is too high. So this will give the station manager an alert that the leakage has exceeded its limit, so they need to attend to it.
The core technological challenges, which includes GSM DNS errors, network connection problems, insufficient power, and refined calibration, must be overcome to pave way for the system to function effectively and efficiently. These challenges affected the seamless transfer of sensor data to the server. Other external factors such as windy days and the release of other gases such as carbon monoxide affected the detection process when sensors are left in the open. This is because it became more challenging tracking only LPG when the weather was windy. To explore more about the detection of LPG leakage at a gas filling station, the system's environment should be studied to tune a good threshold for LP gas concentration.
We look forward to make this project a reality. Hence, in future, we will make a mobile app which will allow us to conveniently view and analyze data. Again, we also look forward to apply machine learning algorithm to learn data inputs which can provide us with a prediction model for gas explosion. We also want to build a portable detector for vehicles which run on LPG.
As an addition to current research on the applications of smart technology to prevent gas explosions, this capstone project shows that the Internet of Things has great potential in early detection of gas leakages at filling stations in Ghana.